Hey everyone, Doctora Mom, Professor Online, back again. So we're looking at the Pearson correlation. So the Pearson correlation specifically is going to measure exactly what it sounds like up there. Sometimes we don't realize that sometimes the name is what actually describes what you're going to do. So correlation. Co means two. Relation, relationship. So relationship between two variables. So it's basically a statistical measurement and describing the relationship between two variables. And describing that relationship is going to be described in a couple different ways. But first, let's talk about the kinds of variables we're going to be looking at. So we're talking about the relationship between two. Can we look at gender and religion? We're talking about male or female, Catholic. Wrong. You can't look at that. The Pearson correlation doesn't look at the relationship between two nominal categorical variables. It looks at the relationship between two variables that produce something like numbers, like income or age, like your age and your income. So it's looking at the relationship between two variables that are scale. In other words, two variables that are ratio or interval data. And remember, ratio has our absolute zero. Ratio data means the fact that you cannot go below the age of 0 or the number of 0. So if we're looking at someone's age, we're looking at someone's weight, these would be ratio data, right? Age or weight. Because age or weight can't go below 0. But if we're looking at interval data, we can look at temperature, because temperature can go below 0. So any type of data that you use to measure in a Pearson correlation has to be the relationship between only two and two variables that are ratio or interval data. So if we look at them then, let's talk about what we need to actually look at the relationship between those two. And of course, what type of relationship it's going to specifically measure. So let's think about we're going to measure something like your age and let's say your income. Now, the way I tell my students to really understand statistics, especially psychological statistics, is always think back and remember. You know a lot of stuff. So the easiest way to understand things that are math-based is to remember that you learned a lot of math in like elementary school, 5th grade, in 8th grade, I'm talking about middle school, high school. We know a lot. We tend to forget it, we tend to freeze up, we tend to freak out. It's okay, not everyone loves math or understands math, but we all use math all the time. And we also learned the basis and foundation of math that allowed us to get to where we are today as adults. So if we think about it, this looks very similar like the scatter plot that we used to use back in the day. When we talked about the X and the Y intercept that we must have all didn't like too much. When I mention X and Y intercept, my students cringe. They're like, no, professor, we're going back to geometry or algebra or trig. I hate that. And I tell them, don't freak out. It's perfectly fine. Just think once again, we're not going to do Y intercept. We're simply going to do, once again, the scatter plot. So we asked every person their age and their income. So every person gave me an X and a Y. They all gave me a value. 2, 4, 6, 3, 4, 2, right? 1, 3. They all gave me a value. Every person gave me an X and a Y. They all gave me their age and they all gave me their income. So when we started actually taking these and we added some numbers, right, without adding real context here, just understanding the procedures of it. If we take these and we actually plot it, and we put all these dots, hopefully you can all see that these dots, if we find a perfect line that fits as close to all the dots together, it leads to a positive slope, right? We're going up and we're increasing. And then we can also talk about how close all these dots are to the red line. So if they're really close together, because we can form this nice little oval looking thing right here, we realize the relationship between age and income is actually pretty strong. So it's a positive, strong relationship measured by its linear relationship. So when we talk about the actual Pearson correlation, it's going to measure a couple different things. It measures then, as you can see there, the direction of this relationship. So is this relationship going up? Is this relationship going down? Is it a positive or is it a negative? If it's a positive relationship, as one increases, so does the other. If it's a negative relationship, it's considered inversed. As one goes up, the other goes down. An inverse relationship. So it measures the direction of the relationship. It also measures the form of this relationship. Look at the form. Is it strong or not? Which leads us then to the third, the strength. Look at the form of this relationship. Is the relationship actually making something that's going to be pretty linear together? Because if we look at it and we were to add in our blue dots, imagine if the dots were here. Can I draw a perfect line of my blue? No, no, no. It goes nowhere. Because if you look at it, this is pretty much like a circle, all these blue dots. There is no relationship there. There's no form. It can't make any linear going up or down. There's no direction for it. And there's no strength. They're so far apart from each other, it basically means that there is no relationship. So the Pearson correlation actually takes two values per person. It takes two values per person because it's going to measure the relationship of two, right, within a particular person. It'll ask every person a question, what's your age, what's your income? It will measure the direction of that relationship. It'll measure the form of that relationship, and it'll measure how strong that relationship particularly is. So besides needing two things, it's going to need, just like we talked about before, all the assumptions. Remember when I talked about the other videos before, the assumptions, or I call the requirements for every single test? So what's your first requirement to run a Pearson correlation? You need to make sure you have two values per person. What's your second requirement? Your data or your variables, right, need to be scale. In other words, ratio or interval data. And when you're actually running this, you actually have to have the third one, bivariate. Don't freak out by words. Bi means two, variate variables. So both variables, right, just like correlationship, both variables need to be normal. Bivariate normality. So each of these, income needs to make a normal distribution, age needs to make a normal distribution, and when combined together, they would be bivariate. Both variables would create a normal distribution. And so when we measure this, we measure always against the population, and we test samples against our population. So this is the one time when all the different videos I've had, instead of using the idea of mu and mean, right, instead of using the mean of the population, we're actually going to switch this, and what are we going to use now? We're going to use rho, which is this curly looking or Greek letter called rho in the population, or we're going to use lowercase r within the sample. So when you see a lowercase r, you know it's talking about the Pearson correlation, or the relationship between two specific variables and how close or far apart that relationship is to each other.